Good morning, students. I am Dr. Sandal Kumar, Department of Electrical Electronics Engineering, VSP Engineering College, Karur. Today I am going to cover the topic on combinational logic design in the subject of digital circuits and design. Okay. So first we are going to talk about what is the need for digital circuit and design. It is the introduction part. Everyone aware about the computer nowadays. Okay, this is the slide. We are showing the components or parts of the computer. In that you could see there is a screen and there is a CPU. Normally, technically we call it as base unit or central processing unit. Apart from that, there is printer and there is a scanner and there is a keyboard, mouse, and for the storage purpose we are using pen drive. So in that you could see the main processing system is that CPU. Okay, it contains the processor, especially the microprocessor. Nowadays, you are familiar with the Intel processor also. These kind of processors are involved in that processing unit. So it will do the process. Okay, this is the main topic that we are going to cover in the topic that we are going to discuss. Apart from this, you could see there is a monitor. It is the input device, output device, and for the input purpose we are using keyboard and as well as mouse. Okay, so apart from the monitor as the output, you have a printer as well as the other memory devices also available. Okay, so that you can store that one. You can see that the pen drive, small red color part is there, that is called as pen drive. In that also you can store. It is also one kind of output source or drive. Now we see computer system components. In the last slide, we could see the picture of the computer system. Okay, in that, what are the major content in that we will see. Okay, the first one is memory. Everyone is aware about what is memory. Okay, it is one kind of storage device. It is used to store instruction. Normally, we say it is a software. Okay, so the instructions in terms of software as well as it will store the data also. Okay, the data necessary to process in the software. So everything will be processed as at the central processing unit. That is the processor in which it has to process everything. And another one is, as we told, input output devices are there. Okay, as we told that input one monitor is one kind of input output device. A keyboard is one kind of input device. Okay. Now we move on to arithmetic and logic unit. Okay, it is the main unit that sometimes it is called as processor. It is involved or put into the processor. Okay, the central processing unit. Okay, in that it has to perform arithmetic and logical operations, so that it is called as arithmetic logical unit. Okay, so next part is control unit, that is inbuilt of the motherboard. Okay, the motherboard itself we are going to place the processor. Apart from the processor, there will be the other controlling circuit that is called as control unit. With the help of that only all the processor are controlled. Okay. Next one is a system interconnection and interaction. That is done by means of the connecting wires, or we generally call it as bus. And another things are the types, available type to get the access the data, the address, data, and control signal. With help of these only we are getting and processing, outputting the data. So next, in specific, when you talk about CPU components, it contains registers. First one is register. It is used to hold the data and instructions. As I told, it is the software, and it could be in various size according to the requirement, according to the usage. It will be in various size and various kind of devices. Okay, like RAM, ROM, these things are available. And there are some specific internal hardwares are available. It is handled by the processor, like program counter, memory address register. These are the internal parts. Normally, it cannot be accessed by the general user. And other thing is the control unit. As I told, when you see there, it is the main unit. It is used to control all over the function. There may be more number of hardwares. Okay, each and every hardware can be controlled, processed with the help of control unit only. And as I told, there is the arithmetic and logic unit. It is the main unit in the overall process. With the help of that only, all the data will be processed by means of either arithmetic or logical operations. And this is the main thing. Okay. As I told already, there is a processor. In general way, it is called as microprocessor. Okay. The way it is called as microprocessor is each and every instructions, that is that software will be executed in terms of microseconds. Okay. So with the help of clock pulse, that is the necessary signal is the clock pulse. With the help of that, the microprocessor will be processed and used effectively. So it takes microseconds to process each and every data step by step that we are writing in terms of instructions or software. Okay, that's why it is called as microprocessor. The processor will do the processing things. Either it can be the arithmetic process or else it can be the logic process. Okay, so that it is called as microprocessor. Of course, for this only we are going to talk about the remaining topic. Okay, how the designing is done for the processor, especially the microprocessor, that we are going to talk about. Okay. So as you see here, to do the arithmetic and logical operations in the arithmetic logical unit, these are the process can be performed. The first one is addition, second one is subtraction, another one is a logical AND. So AND is the general word you could see in dictionary in common English. But here we are talking about a logical AND. This is one kind of process, especially the addition. Multiplication. Logical AND is the multiplication done in terms of binary bits, and logical OR is addition. Okay, binary logical addition it is. Then next one is logical exclusive OR. It is the derived function of and OR. Okay, another one is complement, logical NOT. Okay, complement in the sense if you have 0, its complement is 1. Similar way, if you have 1, its complement is 0. And another logical functions are increment and decrement. If you want to count, there should be two processes. Either it can be increment or decrement. And also it is done by step. That's why the term called add 1, subtract 1 is used here. And another logical operations are left shift. Shift is the general operation, logical operation. The shift can be performed in either way. Either it can be left side or right side. So that here both operations are possible. It is mentioned in terms of left shift and right shift also possible. Okay, it is not mentioning here. However, the right shift also possible. And see that there is a rotational left, rotate right. Okay, so in the shift there will be the end bit will be left over. Okay, but in case of rotation, the left bit again come into the first position, so that it is called as rotate. Okay, there is a little bit difference between the terms called shift and rotate. Another one is clear the instruction. Okay, we call it as generally reset. Okay, that everything will be come to the initial stage. That is called as reset or clear function. So apart from these things, another internal registers are available. It is called as flag. As you see here, the flip-flop, again it is the flag is nothing but register. The register will contain the flip-flop. The flip-flop is set or reset. Set in the sense we are putting 1 in the flip-flop. Reset in the sense we are putting the 0. That the things equal to clear. Okay. So reset equal to 0. So according to the necessity, the things will be happening in terms of set or reset. Okay, it is used to understand whether the program is being executed or it has been completed or it is yet to start. These information will be provided or stored in the flag so that the particular register, particular flip-flop can be accessed to identify by the processor either the processor has been completed or being executed or being started. So these things will be provided by these flag registers. Now come to our major part. Okay, first we talked about computer. In the computer, the one part is called CPU. Okay, in that CPU there is a heart of the thing is processor. Okay, how the processor is made up of, that we are going to discuss it now. So as I told, by means of processor, by using the processor, either you can perform arithmetic operation or logical operation. Everything will be covered in terms of these two operations. Okay. So to do that, certain necessary diagrams, circuits are needed. Okay, that circuit one, there are two type of circuits, or two major circuits are available in digital logic circuits. With that digital logic circuits only, the microprocessor design has been done. Okay, the two type of design aspects are, one is combinational circuit design, another one is sequential circuit design. Now we are going to cover upon about combinational circuit design. Okay. So this is one kind of circuit. It can be used for both purpose. Okay, even though say we call it as combinational circuit, with the help of that we can do both arithmetic operation as well as logical operation. Okay, so now we want to see how it is happening here. Now you see the diagram here. Okay, so here you can better understand how the usage of the combinational circuit. See this, you can see the motion sensor. If some person is moving in and around that sensor, it can sense, it will provide certain output. Okay, sensor is the device. According to the input, it has to produce certain output. Probably it should be the electrical output so that it can be processed by the nearby electrical system. Okay, here the digital system is mentioned, but it is operated by means of zeros and ones. But that zeros and ones also in depth, when you see, it is operated in terms of certain voltage level. Okay, for example, A can be the value of 0 or 1. Similar way, the B can be 0 or 1. I am talking about logic 0 or logic 1, not the numerical decimal values. I am talking about binary values. So in case of A, if it contains 0 in the sense, okay, 0, logical 0 in the sense, it has the value of 0 volt. Similar way, if it contains 1 in the sense, logical 1 in the sense, it has the voltage level of 5 volt. Okay, this way we have to assume the sensor has been designed accordingly. Okay, so if it observes there is no motion in front of the sensor, the A will have a 0. That is logic 0. There is no voltage will be available. But in case there is a movement in front of the sensor, okay, then it will produce a logical 1, otherwise 5 volt, that can be sensed by the nearby digital system. Similar way, there is a light sensor. If a light is provided in front of the sensor, it will provide the output in logic 1. If there is no light in front of the sensor, it will produce 0 at the output. So these zeros and ones will be observed by the detector. Here we call it as the digital system. So based on that, it will do certain logical or arithmetical process. Then that accordingly the output will be displayed or it can be observed. So here the lamp is provided. For example, if A is 1 or B is 1, either of one is 1, okay, it seems that there's a desired performance has been done. When that A will have a 1, according to our discussion so far, when there is a motion in front of the sensor, A will assume 1. Similar way, if there is a light source in front of the light sensor, it will have a 1. So either of A or B is 1, F will provide 1. So how this we are going to get? That makes the design of the component or design of the circuit. That we will see in the next stage. See, when you see here, if 1 is provided, the bulb is provided. So when the output is you are getting 1, it has to be observed in some way. Here for understanding the output, we are using the bulb as the output device. When F is 1, okay, when F is 1, the bulb will glow. If F is 0, the bulb will not glow. Okay, whenever either A is 1 or B is 1 or both are 1, at that time it has to provide 1, that is F has to provide 1, accordingly the bulb will be illuminated. Okay, that will be done by means of certain component. When you see here, we have used certain digital circuit with the help of AND gate and NOT gate. See the diagram. So here that AND gate and NOT gate are logic circuits or logical devices. With the help of that logical devices, that is an AND gate and a NOT gate, we have constructed certain logic diagram. With the help of that, we can observe the content what is expected, as I told now. Okay, so this way the designs are happening. Here note that there is no clock is used. Okay, as I told already, as far as any digital system is concerned, there are two varieties. One is combinational circuit, another one is sequential circuit. Here I am talking about combinational circuit. I tell you why it is called as combinational circuit. There is a specific notation is there. When you see here, you understand what is a combinational circuit. Yeah, digital circuits whose output, that is present output, the required seeing present outputs only depend upon the present input only. The present situation, what is the input, accordingly it provides the output. That is the thing, it is there. Okay, so that it is called as combinational circuit. Okay, so to design these kind of circuits, especially the combinational circuits, there is no need of clock. Okay, so that you could see there is no clock here. Okay, so that so it produces with the help of only AND gate and NOT gate, and A and B is having the necessary input. Accordingly, it will process. Then F will be 1. Okay, that how we are going to design. See that the circuit design, A does not contain any other gates like NOT gate, but B contains one NOT gate. Why it is needed? In A it is not there, but B it is provided. Why? So that makes the design of the circuit. Okay, according to our requirement, we have to follow certain procedure. So that you have to use the component, available logic gates effectively to have a desired output. That we will see one by one in later stages. Thank you.